Started. Thank you all for coming out today on this beautiful Friday so we can have some fun with JavaScript. Today we're going to dive into coercion and truthiness, which contains many aspects that do things very unique for JavaScript. But before I get into that, as always, why is that so dark? Okay, but before I get into that, as always, we'll do a quick review and ask time for any questions. But before that, I just want to talk a little bit about the bootcamp prep pre-work again. So if by the end of today you still feel like you're completely drowning and you're not sure what is going on at all, I advise that you come back to the bootcamp prep pre-work workshop and look through some aspects of that this weekend, maybe specifically the functions section. Because I know the first time that you see this material, it's a lot of knowledge, but you don't necessarily have a mental mindset on how these things are even used in the real life or how you're even going to use them. So it's tricky to save and process some of that information before you even start to use it. So now that we have a few days where we've began to write our own functions and to start trying to use some of this code, if you go back and review this material, it will solidify a lot better the second time around because you have experience to refer to. And so that's not a bad thing at all to admit that we need to go back and review some other concepts. We as programmers have to do that all the time. The knowledge is really iterative, and we'll read an article, we'll process maybe 20% of it, start messing with that type of code, get stuck, and then go need to reread the article again to fill in some of those gaps and just really solidify our knowledge in a better way. So we're constantly needing to refer to material until you really find a mental mindset to think about those tools and really grow to understand them. So that's just another workshop that you can access from the homepage. It's the Bootcamp Prep Pre-Work Workshop. And the videos from the founders of the school should be very helpful a second time around. So before that, before we go to the slides, does anybody have any questions on anything at all or any specific problem from yesterday they would like to review? Okay, so yesterday we covered two of our main looping mechanisms, which are the for loop and the while loop. Can somebody get me started telling me how we can set up a for loop to loop through this string? Okay, so we'll use the for keyword and we'll set up the basic structure here. Now, what are the three pieces that a for loop takes? An initializer, a condition, an incrementer. Yeah, so those are all three expressions, and we separate them with these two semicolons inside here. So when we want to loop through a string, what is a good start spot and a good end spot? How do we dynamically know where to start and where to end for any size string? Yeah, so we want to start with 0 because strings are index-based. And in JavaScript and all programming languages, the indexes are numeric, where the first index is actually 0. So we can set up index here and initialize that at 0, so that we'll start with the first character. Now, where do we want to stop? So we want to continue incrementing I and looping through the string while I is less than the string length. And that's because the string length will be 1 plus the final index, which is very tricky at first to wrap our heads around. And so lastly, what is the final expression I want to do here to move forward in the string? I++. Okay, so let's just pull out our current letter. Does anybody have any ideas on how we can do that? Uh-huh.
So when I watched the solution video, the guy, he wrote I++ at one point and then erased it and wrote ++I. And I think of them as interchangeable, but I wonder if you could talk a little bit about when you would choose each.
Okay, yeah, so there's a slight difference between, let's just put in a num here at 10, and there's a slight difference between this and between this. So in this case, when we have the num plus plus here, it is going to go hit the num and it's going to update the num. But that expression, num plus plus, evaluates to what num was before it does the incrementer. So on line 8, if I log out the result of calling this plus plus operator on num, I see that I actually get 10. But on the next line, if I look at what num is now after line 8 has fully ran, we see that num is 11. So num did get incremented, but this expression in here evaluated to num was at the time. So if I just flip this around and I put the plus plus here, it's going to do the opposite. What do we think is going to be logged out on line 8? 11, exactly. So we still incremented num, and we still see that that result is saved on line 9. Num has been incremented. But on line 8, the position of the plus plus determines what that expression evaluates to at that time. So plus plus num will increment num and then give you the new value, whereas num plus plus will give you the value of num and then increment it. So this isn't really something that's going to affect our for loops because we don't care about what this expression actually evaluates to. We just want that work done where I will be incremented by the time we go back into the code block. So it will be specific edge cases where you're actually looking at the value of num while you do this. But for now, if that's confusing, we don't have to worry about it too much. We can just code around it and check the value of the data type afterwards. And so to be safe, I guess plus plus and then the data type is safer to start with if you're going to want that incremented value. So that might not make too much sense. It's a very niche aspect of that operator. But for all intents and purposes, in the for loop, we could do the plus before or after. It doesn't matter what the value of that expression is going to be. We just want the work done that I will be incremented. So that's a great question. So yeah, we have this incrementer that we know it's just going to be some integer that's going to increment for the length of the string. And so to access a certain character in the string, we just have to plug in a numeric index. So at the start, when that index is 0, and we plug 0 back into my favorite place, we're going to get that f. And I actually need to log that out to see that that has happened. So we pull out the current letter at 0, we log that out as f, and then we go increment I. And now when we pull out the letter again, I is 1. So the first numeric index of my favorite place is this u. And we continue so on until we've gone through the length of the string. So how can I flip this? How can I process this string backwards if I wanted to? Well, that's a start. Yeah, we're definitely going to go backwards, but right now, that's not enough. What else do I have to change in my for loop? Okay, so we have to start at the end of the string. How can we start at the end? Of the let I equal what? Yeah, so 10 will work for this specific case where full stack is my favorite place, but really we want this for loop to work for any size string, so it needs to be dynamically calculated at that time. So as Sahil said and a few others over there, we want this to be the final index, and so the length is not the final index, it's the total amount of characters in there. The final index is actually the length minus 1. So this will start I at 10, which is what you wanted to achieve, but this will work now even if we change this to a smaller string. However, this still isn't completely done yet. What else do I need to fix in that for loop? Exactly. So we've kind of just flipped this. Instead of starting I at 0, we're now going to start I at the final index, and we're going to continue while I is 0. And as soon as I hits -1, we're going to break out of this for loop. And every time we run that code block, we're now decrementing I instead of incrementing it. Any questions on that? Cool. So type coercion. Basically, it's a double-edged sword because in JavaScript, we don't have to declare the types of data that we want to store into a variable. In other languages, if we want to say that, hey, we need a piece of data that's going to hold integers, we have to tell the compiler, hey, my num is going to be an integer. And if we put a string in there, it's going to throw an error. But in JavaScript, it doesn't care. We can define variables to hold any type of data, and then we can update them and make, we can assign that value to any data type. So in this case, the name of the variable myString is purely for humans. JavaScript doesn't know what that means. It doesn't care at all. We're not telling JavaScript anything about the type of data that we're going to give it. And so this means that later on, when we try to perform some operations, such as maybe adding a piece of data that holds a string and adding a piece of data that holds a number, JavaScript will perform internal rules to decide how to treat those different data types and what operation it should actually perform. In typed languages, where we have to declare that this piece of data will always be a string, if we try to add a string with a type of data that's labeled as a number, it will throw an error. So as beginners, that adds a little bit more mental overhead to learn the other languages and plan out your data types and how to achieve the effect you want. But JavaScript is a lot looser. It won't give you errors when that happens. So instead, it means that it's even harder for beginners because we have to learn about how JavaScript thinks about these data types and understand its behavior. So before we go through the slides, we're just going to do a rough draft of the slides with a few examples of these types of things at work. That way, when we hit the slides, you already know a little bit about how it's used and where to fill in the gaps. So when we're talking about data types, we've got this very important type of operator. So you can think of it like a function. You can think that we're calling type of on my string like this, except it's just a special keyword in JavaScript that's known as a language construct. And so it's basically an operator, just like how we have my string plus my num over here. It kind of works the same. Type of is just going to perform its operation on whatever is to the right of it. And so what type of does is it returns a string describing the type of data that we currently have there. So in the case of my string and my number, we see that we get the word string to describe that my str is a string. And down here, we get the word number to describe that my num is currently a number. And so if we change my num to equal whatever, we see that JavaScript doesn't care that it used to be a number and now it's a string. It's just going to tell us what the type of this data currently is. So that's a very useful operator that we're going to want to use to just pop into REPL and check things out and mess around and see what happens when we add these values together. And it's a good sanity check to fill in the gaps and just mess around to see what JavaScript actually does under the hood and what type things relate to. So over here we have another example where my string used to be the string hello, and now it's still a string that holds some numbers in it. And so when we log out that type, we get string. And so this is a string clearly because it's got the quotes around it. That's how JavaScript knows to build this thing as a string. It doesn't actually care what the characters are inside of there.
Does it make a difference with a single quote or double quote?
No, there's no difference between the single quote or the double quote. That's a good question. So now I'm setting my str back to the string hello, and I'm setting my num equal to the number 10. And down here, I'm going to do some weird JavaScript magic where I add these two data types together, even though they're actually different types of data under the hood. So what do we think is going to happen when I add hello with the number 10? Yeah, concatenate. Yes, that's correct. So down here, we basically plugged in the number 10 and added it to the string hello. This is kind of the first thing JavaScript is going to do when it begins to process this operator. Before we can process this operator, we have to figure out a single value of each of these things on the side. So it's going to look up on the scope, which we'll talk about in the next day, and find that my num is currently equal to 10 and plug 10 in here. Then it's going to plug in the string hello over here. And now JavaScript has a set of internal rules for all of these operators that explain what it should do when it needs to add a Boolean and a string, or in this case, a number and a string. And so the JavaScript creators decided that it's easier to convert the number to a string and then concatenate the result of both of those. So what it's going to do is it's going to come to this number and it's basically going to convert it to a string just by dropping quotes around it. And so now it's got a string and a string, it's just going to smash them together. So we see the result of adding these two is the string 10 hello. And we could double check that type down here with the type of operator. So it's important to know that with all the different data types in JavaScript, there are actually 36 internal rules that describe what to do when we do all sorts of weird stuff like add arrays with Booleans or add objects with arrays. In reality, we're programmers, we're lazy, we're not going to go learn all 36 of those methods, we're not going to study them, we're not going to memorize them. So instead what we need to do is we just need to learn the basics of what happens with the data types we're more frequently going to operate on. Like string and number is one that's going to basically become muscle memory and we won't think about it too much in the future. But with other things like adding an array with a Boolean, stuff that doesn't really make too much sense, we don't care what JavaScript does under the hood. We should just set up our code in a way that we're not going to fall back to these ambiguous rules. If we're adding an array with a Boolean, I'm not sure what your intended effect is anyway, so we probably don't need to do it. So anything that's complex like that or really technical, just write the code in the way that you know works a majority of the time and you know directly what is going to happen. Like a string and a number is a very determined effect. We know it's going to stringify the number and smash them together. So we'll go over a few more of those as well. I'm sorry? What?
7 o'clock.
7 o'clock.
What about 7 o'clock?
Someone's big speed is just like.
Okay. All right, so what happened here is what's known as implicit coercion. We didn't specifically tell JavaScript, hey, go take that number and make it a string. But under the hood, JavaScript says, hey, for me to be able to do this, I need to convert one of these values to a string. And so Java implicitly coerced my num into a string. There is this concept, though, of explicit coercion, where we can tell JavaScript, hey, I've got one data type, I want you to force it into another data type. So down here, we're defining a number as num, and we're setting that equal to 10. And over here, we're using this global class inside of JavaScript, the actual string class, the string constructor, what JavaScript uses under the hood to create strings. And so all of these data types have a class within JavaScript that we can reference, and we can pass them a data type that will basically take whatever it was and coerce it into the type that we're referencing. So in this case, I'm saying, hey, JavaScript, go build a string out of whatever this piece of data was. So it used to be a number, and now when I explicitly coerce it to a string, we can't really see that in the terminal. We can't tell that that's really a string. So as a sanity check over here, we will confirm that, hey, num string is now a string. Yeah?
If you just go before where you had where it implied that the number 10 became a string, what if you did the multiplication sign? Would it still recognize it as just a string, or would it force it back to be a number?
Yeah, so that's a great example of one of these lesser known rules of JavaScript. In reality, we don't really, what is the idea of multiplying a string with a number? What are we trying to achieve?
To create the number, the amount of time, to create the string, the amount
Okay, so that's what we would like to happen, but what does it actually do? So let's just plug in the number 2 here and multiply it with hello. So what happened here when we tried to multiply 2 with a string is we get back this other value, this NaN. Has anybody seen NaN before?
Yes, not a number.
Yeah, it means not a number. It's a special value in JavaScript to say, hey, I had no idea how to do whatever the hell you're trying to do. There is no rule on what to do when we say multiply a string by a number. It would be great if it would just concatenate 2 hellos together. Maybe that would be useful, but JavaScript is not coded like this. So instead, it's basically going to give us this NaN and say, hey, I can't do that. So we have to be a little bit more creative and figure out how to push that hello together multiple times. And does anybody have an idea on what we could use to do that? A for loop. So inside that for loop, we can basically add the string to some variable that we're going to build a string up on. And we can set that for loop to loop from 0 up to 2. So in other words, it will perform itself twice, and it will concatenate the hello twice. So we have to manually put in those instructions to make it do what we want. We can't really use a really math-based operator to achieve that effect. So the multiply and divide and modulus operators are probably going to give you NaN if you try to perform them on anything that isn't both numbers.
And I might be wrong about this, in Ruby, and I don't mean to bring up, but can you do that in Ruby though?
Off the top of my head, I learned Ruby for like 1 week. I've got no idea.
Oh.
So any type of data in JavaScript can be converted to another type. And JavaScript has built in all sorts of rules depending on what the 2 data types are to determine what it should do. So for instance, every type of data in JavaScript have rules that determine its truthiness. And this is something that we're going to use over and over again. We want to know if basically a string is true or if it's false. And so JavaScript has built-in rules to convert everything to Booleans as well. Where's that other console log? So down here, we wanted to know, hey, what is the Boolean value of this string that has some characters inside of it? And basically, the rule is any string that has characters in it will be truthy. So when we explicitly coerce this string into a Boolean value, we see that the new value is the Boolean value true. And if I do that with an empty string, we see that it's false. So the only rule there is that a string that has characters is true, whereas a completely empty string is false. So that's an empty string that has no characters inside of it, but if I put a space, it's now true. That counts as a character. It's taking up some space, and so that is a truthy string. So explicit coercion, like what we're doing here, where we're specifically saying, hey, we want this thing as a Boolean, it's not used as often in the real world, but it's great to sanity check and to play around and see what happens with these different values. Instead, in the real world, we often rely on what is known as implicit coercion, where we're writing some code and we know JavaScript is going to convert the types for us. And so JavaScript will automatically coerce those values when we perform operations or put them in what's known as a test expression. Test expressions are the things that go right next to your if, or in the while condition of your for loop, or just the condition of the while clause. So down here, we already saw a little bit about some implicit coercion. When we add this string with this number, we're letting JavaScript decide how to handle that. And it's going to coerce those values and smash them together. Now down here, I've got a Boolean value true, and I'm trying to add the Boolean value true with the Boolean value true as well. Any ideas on what this is going to do? So, a little less intuitive, what JavaScript does is when it first has Booleans, it converts the Booleans to number values. So a truthy value will be 1, and a falsy value will be 0. So when we take true and we add it to another true, it's going to do something like this. And that's kind of the steps JavaScript just took to implicitly coerce these values and perform this concatenate operator onto Booleans. I know it seems like a lot at first with all these different rules, but we just need to learn the ones we're going to use most often, like adding Booleans or adding strings and numbers. We don't really care about the multiply or the divide or some of these more ambiguous things because that's not the type of logic we need to achieve. So another time that JavaScript will coerce values is when we're comparing values. And in JavaScript, we have two operators to compare values. The first is this triple equal sign. And what that is saying is, hey, let me know if the expressions or the data on either side of this operator, they are the same type and the same value. So when I log out if 10 is strictly equal to the number 10, we see that that is true. They both are a type number and they both have the number value 10. But if I strictly check whether the number 10 is strictly equal to the string 10, we get false. So JavaScript didn't do any coercion here. It checked if they're of the same type and if they're the same value. So right here it says, hey, I've got a number, I've got a string, I'm not even going to do anything. They're not strictly equal. Now if we just drop one of those equal signs off, we do what's known as a loose comparison. And so a loose comparison means that we allow JavaScript to perform its internal implicit coercion rules to get both of those data types into the same type of data. Once it coerces those values, it then checks if their new values are the same. So in this case, when we loosely compare the number 10 and the string 10, JavaScript says, hey, it's easier to make a number into a string than to make a string into a number. So it's basically going to step in right here. It's just going to add quotes around this guy and treat it as a string. And now the string 10 is loosely the number 10 is loosely equal to the string 10 because when we convert the number to the string 10, the value string 10 is the same as the value string 10. Does that make sense? So the most often time that this occurs is within test expressions. And what I mean by that is when we set something up like this. So up until this point, we've mostly been using operators such as if my num was greater than 0. Because greater than, less than, greater than equal to, or less than equal to automatically will become a true or false value, just as we use them in English. But if we drop that off, over here what we're saying is this value truthy? And so the process JavaScript is going to step through for that when it starts to parse this if my num is first it needs to plug in the value. So it gets the value 10 from my num and it's now if 10. And so to figure out the test expression, JavaScript says, hey, whatever value I've solved to, I now need to know the Boolean value of that. And so the Boolean value of numbers is pretty much any number that isn't 0 is a truthy number. Only 0 is a falsy number. So under the hood, it's coming in and it's pretty much going to just convert this number 10 to a Boolean value. And 10 is truthy because it's not 0, so we now basically have if true. So 10 was truthy, which would mean that this bit of code would get executed down here. Any questions on that or where we're headed with these coercions and test expressions and the operators? All right, let's move to the slides. So we're going to talk a little bit more about the types in JavaScript, as we just saw a few of them. We're going to talk about how to explicitly coerce them, which is when we're calling these JavaScript class methods and trying to change a type into another type. Then we'll talk about implicit coercion, which is where the real JavaScript magic happens, and is one of the reasons that people may talk some shit about JavaScript because it has some crazy rules that don't really make too much sense. It's also most often used with concatenation and the loose equality operator. But more importantly, we really need to learn the rules of truthiness. What types of data are true and what are falsy? We use those within the conditional expressions or with this bang operator. That's what the exclamation mark is down here. We'll talk about this later, but what that's saying is, hey, is this thing not truthy? It's basically going to coerce it to a Boolean value and then flip that value. And then lastly, logical operators like and or. How are they used and what are they doing under the hood? So types, the types that we've seen in the examples just now and that you've probably worked with a majority of your time with JavaScript so far are numbers, strings, and Booleans. And JavaScript doesn't have too many rules about those. Numbers can be any number, not just an integer. It could be a negative number, and they can get pretty big. I'm not sure what the final value of numbers are, but in other languages, we have to tell the compiler the size of a number. We have to specify that, hey, this is going to be a decimal, or this is going to be a large number with over 12 different digits. JavaScript doesn't care. Anything that we know as a number from math is a number to JavaScript. Strings are anything that are within single or double quotes, and JavaScript will just use them as a list of text characters. And Booleans, there are only two values, true and false. So these are all primitive types that we will use most of the time when working with operators. Other primitive types are the value null and undefined. So undefined we've seen before. If we try to access a string at its length, we'll get undefined because the final index of that string is the length minus 1. And so there is no character that's beyond that index. Undefined is JavaScript saying, hey, that value you tried to access, it doesn't exist. So I'm telling you it's undefined. Null, however, signifies an empty value. JavaScript will never give us null. Instead, null is used by a programmer to say, hey, my current user is equal to null. And then when they log into the program, we'll fill in that variable with the user data. So it's used as a way to say, hey, there's going to be some data here, but it's not here yet. So if I look at it, I want to know that it's basically falsy.
It's just waiting for user input.
Pretty much that's how we as developers are going to use it. It's a value that will be filled in later, and it's only put there by developers. If we ever try to access a value that doesn't exist and we haven't said anything there, JavaScript will give undefined. Null is a way for us to put a value there, but say, hey, it's not really filled in yet. Lastly, there's this new type called symbol, and that's not covered in this course at all, so we don't have to worry about that.
Can I just ask a quick question?
Yeah.
This is a bit of an aside, but so you know how like when you're defining a function, you're making an optional variable for
Yep,
argument?
yep.
And so like you set it to a value like 0, and then it will automatically change if the user inputs a different value.
One more time.
So let's say I was defining like you know, my num equals, let's say I set it to 0, right? Just to put a value there, but it will be changed once the user inputs something into that function, right? If they don't, it'll remain set at 0.
Yeah.
You know what I mean?
So in here we have a function that takes two values.
Right. So let's say
So in this case, I'm calling it with just the number 10. Okay, so what do you want to happen?
what I'm saying is, what I've seen presented is that if you wanted to make a variable optional, right? So this could be set to 0, like I leave it set at 0, or the user could update it if they input something else into this, or into this function, right?
Yeah,
So another argument could be called to this function. So it could be 10, right? If you input 10, but I may set num1 equal to 0 as a default,
yep.
right? Is that a place where null is used?
Yeah, so I'll show you in a second here. But basically, let me get that other console log out. So in this case, we have a function that we told JavaScript, hey, this can get called with two arguments. The first thing I'm going to know as num1, and the second thing I'm going to know as num2. Now on line 86, I'm trying to invoke this function and to run the code block, but I've only prepared one of the arguments. And so we see here that num1 is 10 when we called it down here with 10, but num2 is undefined. So if we wanted to set a default argument in here, we could say if num2 is strictly equal to the value undefined, because undefined will only be here if they didn't put any data inside of it. Then we want num2 to equal 0. And so we see here, if I now run this, num2 has been set to 0, even though the user didn't give me a value.
So I've seen before, right, where, like, let's say num2 is like, yes, exactly.
Yes.
So is that okay? And I'm just trying to think of use cases for, like, null and things like that. Just trying to think
So,
of how to apply this in
I don't want to confuse you because this is, not necessary at this time, but if you're aware of it, we can define default values in our function signature. And so that's done by this equal sign in here. And what it's saying is, if they don't give me a num2, automatically set num2 to 0. It's basically doing the same thing as this, except JavaScript gives us a shorthand way to achieve the same effect. So in the case that I call it with just 10, num2 will default to 0. And when I actually fill in an argument over here, we take the argument the user provided us. So that's something to be aware of. If you're aware of it, you can maybe skip writing out these lines. But it's not entirely necessary right now. It's a great question, though.
But I'm just wondering if, like,
No.
so instead of 0, yes, is that a place where the null might realistically be used, or no?
I mean, it could, but really, if this thing gets set automatically to undefined or null, and I want to know if it's truthy, it's going to have the same effect. Both null and undefined are falsy. So instead, it's more likely that you would see let current user equal null at the start of our program. And so in here, we have a function called loginUser. And when they click that login button, we're going to go get their data from the database. We're going to skip that code, obviously. And then we're going to say current user is equal to the user. So just as an example, we haven't seen objects yet, but pretend this is an object representing the logged in user. And when they click a button, we now invoke this code. And we see that current user has now been set. So this means that at the start of our program, we can set it to null. And now elsewhere in my code, I could say, hey, if we have a current user, display their name in the top right. But if there is no current user, if current user is falsy because it's a null value, then don't display their profile in the top right. Just do nothing. So that's more likely how we would use null in the real world, waiting for data. But inside of the functions, the undefined will achieve the same purpose.
So is there an advantage to adding the null? Sorry, I'm just curious about this. Rather than just having the semicolon after current user and leaving it undefined. Is that like for other programmers who are going to read this code in the future, or is it advantageous for the
No, it's definitely smart style because it makes it obvious to who's ever reading it that, hey, this thing isn't defined now, but it will have a value later on. And it doesn't necessarily have a different effect because if we try to perform any operations on an undefined or a null value as if they were actually values, we're still going to get an error. So it's more so just stylistically and to be explicit with what is expected from this code, that we want to set null where we know that that thing is currently empty and let undefined be more of kind of like a thing that means something is going wrong. Does that make sense? Great questions. So we covered this slide. Let's talk a little bit more about types. So what were the primitive types that I just mentioned on the previous slide? Booleans, numbers, strings. Yeah, those are the types that we'll most often use with operators. Yep, null and undefined as well. And so all of those have explicit rules to coerce to each other, and they make a little bit more sense than working with these complex data types. So the complex data types in JavaScript, one is a function, which is that special bit of code that we define that has the ability to be run over and over again. And the other two are arrays and objects. And so arrays are basically ordered lists of data. And objects, as we saw that user object, they're a list of key value pairs where I said, hey, on this object, the name is actually the value Chris. So arrays and objects are used more often to represent things in real life, like we made a user object, or we'll make an array list of my favorite places. How do we multiply a number with a list of places? It doesn't really make sense. So the implicit type coercion between these complex types and the primitive data types is usually going to be completely unusable and not really make too much sense at all. So we don't have to read into the JavaScript and what it's actually doing under the hood. We just have to take care to know what data types are primitive and what we're going to use them for, and not do wacky things where we try to add 10 to a list of data. So only complex types can be mutated, which means, this is a whole lecture on this, but what that means is we did this example yesterday. So it's showing up in blue there because I can't name a piece of data string. JavaScript has saved that word into JavaScript. And if I try to run code, it's going to say, hey, I need that word. You can't use it. So that's why it's showing up in blue here. And I just have to change that and not literally call it string. And so in here, if I try to access the string at 0 and say it's now equal to C, and then log out that string, we see that the string variable here has not been changed. We can't mutate that. That primitive data type, we can only reassign string by reassigning it to a completely new value. So in this case, I could have said string is equal to the character C plus this slice method, which is basically going to say, hey, go start at the first index and cut from here to the end of the string. So in here, I have the character C, and over here, I'm going to have ELLO. And so now we perform that operation. This entire expression evaluates to cello, and then we've reassigned string there. So we had to totally reassign a variable that was holding a primitive data type to actually change it. So in other words, it's not mutable. I can't just go to string and update data inside of there. I have to update the entire value. Arrays and objects are a bit different. Once I've defined my current user, I can go in there and say, hey, current user.name is now equal to something else. So that's all that point on the slide is saying, and we'll have another lecture devoted to that in its entirety. Why is this happening today? So the reason for that, the concept behind is that primitive types are passed by value. It means that whatever that operation is, we need to resolve it to a single value, and then that value gets assigned to that piece of data. We can't update that value. We have to fully reassign the variable. Whereas complex types are passed by reference, which we'll cover entirely on the whiteboard another day. So explicit coercion. We saw a little bit of this in the pre-lecture REPL, and that is when we're using one of the global JavaScript objects to create a value of a new type. So in this case, we made a piece of data to be the value, the numeric value 10. If we log out the type of that, it's going to be a number. But down here, we're now saying that this operation should take whatever this thing is and coerce it into a string and save that value as string. So if we log all of those out, we see that number was type number. Down here, we created a string out of it and stored that as string. And when we log that out, we see 10, which we can't tell right there that it's a string, but it is. And so to double check that, we said, hey, what is the type of string? And we get back the string, describing that. And here we just have the reverse example where we have a string that is storing numeric digits, but JavaScript doesn't care about that. If we have the string quotes around it, it's going to treat that like a line of text and save it as a string. So 1,000 quoted is a string. Now down here we say, hey, create a number out of that string. And so it looks the same if we were to log it out, but we log out the type and see that it's now a number. Make sense? So implicit coercion. This is the JavaScript magic that we have to wrap our heads around and work with. Implicit coercion changes the type of a value. Unlike explicit coercion, implicit coercion is something that JavaScript does for us behind the scenes based on the operators we're using. We don't explicitly tell it to convert those values, but it's going to do it. And so this behavior can be very helpful, but it's really important that we understand how it's going to work with our data types so we actually know what the code is going to produce. So this is an example of implicit coercion. Well, on line 5 it is. But to start, we say, hey, let sum equal to the sum of the numbers 10 and 20. So that's easy. Those are numbers. It works how we use it in real life. Sum will be equal to 30. Then on line 3, we concatenate two strings. And that works also kind of how we would expect it to. It's just going to smash 10 and 20 together. But when we try to add a number value and a string value, JavaScript actually converts the number to a string and then smashes them together, which is why not sure is the same as concatenated string. Because before it could perform this, it created 10 into a string, which is basically the same as this line. Make sense? So where did that 10, 20 come from? It's the same value as adding the strings 10 and 20. The plus operator has rules behind it to implicitly coerce a number to a string if you try to add a number and a string. So now in this case, we follow the order of operations that we follow in math, which means that if we have all pluses, we're going to work from the left to the right. So as soon as we start on the left, we add 10 and 20, and we get back that string 10, 20. So now it's the string 10, 20 plus 30, and that will become 10, 20, 30, and so on. We're consistently adding a string to a number. And so the final output is basically a concatenation of all of these, just because we had one string at the start that made everything become a string. It's worth noting that if I put a multiplication sign over here, we would follow the order of operations where 40 would get multiplied by 50 first. Then we go back to the left and start smashing strings together. And at the end, this value would be, 2,000? And that would get smacked onto the end of 10, 20, 30. So in this case, we're following that order of operations again. We're starting all the way on the left. And so 10 plus the number 20 is 30, and 30 plus 30 is 60, and 60 plus 40 is 100. Only at the end do we have the number 100 plus the string 50 that causes this implicit coercion to smash that 50 onto the end and now build a string. So as we saw earlier today, the trickiest part of JavaScript is when we use this loosely equality operator, because that's the thing that really has that large set of 36 rules to implicitly coerce values to the same type before comparing them. So we start easy. We compare the number value 10 and the number value 10, and we're saying, hey, when these things are the same type, do they have the same value? And so right away, the numbers, they're both numbers. It doesn't do any coercion. And the number value 10 is 10, so that is true. That operator results in true. Down here, we want to know if the number 10 and the string 10 have the same value when they're converted to the same type. So JavaScript just wraps strings around this number, and they are the same string, the string 10. Now in this case, it doesn't, when we've got the string true and the Boolean value true, JavaScript doesn't really convert that string into the Boolean value true. Off the top of my head, I'm actually not even sure what it's going to do here.
It wouldn't translate the Boolean value into a string?
I'm sorry?
It wouldn't, if Boolean value into a string?
No, it's not going to do that because, I mean, the odds of us having that would only work with the strings true and false. There's just so many different values that a string can take that that's not going to be useful in a majority of the time. So I think actually what's happening under the hood is JavaScript is converting both of them to numbers. And so to get the number of a string, basically you can imagine that each character in text has a code behind it, where we can imagine that the number 0 has the code 0. And the letter A might have the code 26, where B is 27. And then like an uppercase A might be around like 56. Does that make sense? That text characters get mapped to numeric values? So in this case, it's going to convert the Boolean into the number value 1. And then with the string, it's going to add up the character codes of each of those characters of text. And that's definitely going to be greater than 1. It's not going to be equal to 1. So if I put an empty string in here and wanted to check if the empty string was loosely equal to false, the empty string has no characters in it, so the total would be 0. And false, when we convert it to a number, would be 0. So in that case, it would actually be true. But in here, it's pretty weird, and it's something that we would probably want to avoid.
If you're having that situation and the first thing that's, let's say line 5, and you have it as 2 times 5, implicitly equal to 10, would it do the math first and then convert it into a string?
Exactly. So this operator, to perform, it needs to reduce the expressions on either side to a single value. So we're going to have to solve the left-hand side first, which is 2 times 5, and that equals 10. So we've got a single value on one side. Now on the other side, we need to reduce that to a single value. But in the case that it's the string 10, we have it. So then we could check the number 10 equal to the string 10.
One small question, just because I went over the JS Jumpstart course, and I mentioned in a minute I wasn't sure if I 100% understood for the character values when it's evaluating a string. Is it just using Unicode IDs?
I believe so, but this is an implementation that can change based on the browser and who configured that software,
Okay.
which is why those are some of the pitfalls of JavaScript. So we would see that sometimes if we sort those values, you get different results in different browsers based on differences in the codes they're using for the text.
But wouldn't that result in not a number?
I'm sorry?
If you converted a string to a number, it would result in NAN.
No, if we, let's just visualize it. So we've got our string here, and it's not, this time it's not actually text characters inside of it. So let's see what the number operator does when we call it on the string. Oh, in that case it did do NaN. Then I guess the Boolean in the example that's over here has an extra step inside of it where it converts it to a number. I didn't know that. Straight up, that would do NaN. Good call. So down here, we see kind of the reverse of what happened on line 6. On line 6, this evaluated to some number that was greater than 1 because it did add up those character codes to convert that string to a number, which apparently doesn't happen if you explicitly coerce it. But on line 8, we see that true is equal to the string 1. And that's because true gets coerced to the number value 1, and the string 1 gets coerced to the number value 1. So they are the same after coercion. So values can be explicitly coerced to Boolean values as well. And this is basically the concept of truthiness. We want to know if a piece of data is true to move on and do some logic. But if it's not true, it's falsy, we want to avoid that. So very often we're checking the truthiness of a variable. And that's the same thing that's going on when we explicitly coerce a data type into a Boolean. So down here we want to know the Boolean value of the string I am a string. So that happens on line 3, and that Boolean value gets saved as new bool. Now if we log out new bool on line 5, we see that it was the value true. Why is this truthy?
Because it has characters.
Because it has characters in it. Yep, that's the only rule for strings. If they've got characters, they're truthy. If they're completely empty, they're falsy. Oops. So when coercing a value to Boolean, JavaScript uses a set of predetermined rules to determine if a value is falsy or truthy. Values that end up being true are what we call truthy, and values that end up being false are what we call falsy. Most values are truthy, which means that we really just need to learn the rules for when something is not truthy. And so like we said with strings, a filled-in string is true, and with numbers, any number that's non-zero is truthy. However, with complex data types, as soon as they exist, they're always truthy. So if we create an object or we create an array, we don't have to put anything inside of there. Just by it existing, it will be truthy. So even if I deleted everything that's inside of these, just the presence of those curly brackets for the object or the normal brackets for the array make that thing truthy. So all of these are true. And these are the falsy primitive data types. So an empty string is falsy. The number 0 is falsy. Null, undefined, and NaN are all falsy as well. We don't want to operate with those things. So those are the main rules that we need to learn about truthiness with the primitive data types, all on this slide. So in this case, JavaScript is always going to perform implicit coercion on the value that is inside of our test expressions. In this case, when we use the greater than, less than operators, just by comparing 5 being greater than 0, we straight get a Boolean. But I could have just put in if 5. And 5 would get coerced to true, and that would run the if part of this block. So the greater than, less thans, they always evaluate to non-Booleans. And in this example, we have an example of a value that does not resolve to a Boolean right away. The single value here is the string apples. So JavaScript will implicitly coerce that string to its truthiness. So which console log in here will get run? The first one. Why? Because it's a string with characters, exactly. So it's truthy. So in this case, we see the same result with numbers. If the single, whatever expression in here evaluated to 10, maybe we did some math and there were a few operators in here. Before the if even works, we need to get a single value. So we've just skipped those steps and plugged in a single value here, the value 10. And down there, we did it for 0. So in the case of the number 10, it's not 0, so we log out yes. 0 is the only falsy number, and so in that case, we log out no and hit that else block. Now, there is another way that we can coerce things to Booleans, and that's this bang operator, or you can think of it as the not operator. And so it's an operator that coerces a value to a Boolean value and then flips it. So in this case, we've got this single value true. It's already a Boolean, so we just flip it and we get the value false. Down here, this not operator says, hey, convert this thing to its Boolean value. It's a string with characters, so that's true. And then the not flips it to be false. And then we repeat that process down here. This is a number, so it's truthy, but not true is false. And these are complex data types that are always truthy, and not true is false. Does that make sense? So it's worth knowing that we can put two bang operators next to each other, which is basically going to coerce to a Boolean, flip it, and then flip it again. So in the end, the end result is just the truthiness of that thing. So over here we've got true. It's true. We flip it to false with the first one, and then another one flips it to true again. So this is basically a shorthand way to get the same result as when we explicitly write Boolean from a value. Just shorthand way to convert it to a Boolean type and then flip it twice. Then we've got logical operators, which are how we can build up more complex test expressions. So, is this the first slide? So in this case, how the AND operator works is a little bit tricky. But what it's going to do is it's going to return, this thing will result in the first falsy value or the last value. So in this case, 10 is true, so we move on, and 20 is true. So the result of this operator is to take the last value. So this thing replaces with 20. And now if 20 is true, so it will log out both 10 and 20 are truthy values.
Why does it ignore the first one?
Let me just put this in a REPL real quickly. And so syntax error line 104, it's this white space character ruining my day. And we already named something num, so we have to name this num2. Okay, so why?
I understand the concept of the double ampersands.
Mm-hmm.
I understand that completely, but why, I'm just asking, I guess theoretically, why does it ignore the first value?
So the AND operator, it's just set up that it's always going to result to the first falsy value or the last value. And that's because we can set up logic where we say, so let's say we've got so basically, if I try to access in the example where we've got this current user object, if I have code that's trying to access the name property of current user, but current user doesn't exist yet, it will throw an error. We cannot read the property name of null. So we use the AND operator to protect our code. So over here, this thing will possibly be a name. And what it's saying is that, hey, if the current user exists, then I can get the current user name. But I don't even want to try to get the name if they don't exist because it's going to throw this error. So the AND operator lets us protect our code so that we only can go deep if everything else is already present. So that's a little bit more advanced. We're most often going to use these within test expressions like on this line. And that's going to result in a truthy or falsy value and operate the way you would expect if 10 and 20 are true. Really, under the hood, the AND operator will resolve to the first falsy value. And so if a falsy value, it will be false. So this is the more advanced use of it. And it's to protect our data and give us a way to set up logic gates when we assign values. So under the hood, for this AND operator to perform, it's coercing each term into its Boolean value and then deciding if it can continue. So in this case, 10 is truthy, so we move on to 0. 0 is falsy, and it's also the last expression of the AND. So this is going to result in 0. And then if 0 is falsy, so we won't step into that code block, and instead we'll log this out. So for now, this is the most common way that you're going to see these logical operators used. And here on this slide, we explain that concept a little bit more in detail. But the AND operator returns the first falsy value or the last value if all are truthy. So in this case, the returned value of the combined operation of all of these operators is going to be 0 because we said, hey, 10 is true, so let's move on. Apples is true, so let's move on. 0 is falsy, so this entire expression evaluates to 0. And we can log that out and see that there. Now down here, all of these things are true, so the final result is 7. And that's how I would be able to get the username, only if the user already existed. The OR works in the opposite way. It's going to return the first truthy value or the last value if all of them are falsy. So in this case, null is falsy, undefined is falsy, but happy is true. So the returned value will be the string happy. And if this was a test expression that said if null or undefined or happy or pumpkin, it would evaluate to true because we would pull out the true value happy, and that's true. Now down here on line 7, we get NaN because that's the final term, and all of these are falsy. False is falsy, null is falsy, 10 is not less than 0, so that resolves to false, which is falsy. And then this is the final term, so we just take NaN, which would be falsy if that was a test expression. Any questions on those? Oops. So, to recap, we went through some of the different types. What are the primitive data types? Again, Boolean, number, string. What else? What are the ones that are always falsy? Correct. So what is explicit coercion?
It's when we coerce the change in the variable.
Yeah, how do we do that? Well, yeah, so explicit coercion is when we use the built-in JavaScript classes, that capital S string and that capital N number function, which say, hey, convert whatever I give you in this function into the type that I'm currently calling. Now, the triple equal sign isn't going to perform any coercion at all. It's just going to check if they are the same type and value immediately. The implicit coercion, however, happens when we give different data types to an operator, like that plus operator, or the multiply operator. When we tried to multiply a string with a number, we got back NaN. So there are a bunch of rules that tell those operators how to perform based on the data that they're giving. And we saw that a number plus a string will smash them together and convert them both to a string. The loose equality operator will also perform implicit coercion. It says, hey, I want to know if these things have the same value after I make them a similar data type. And then more straightforward when we use these coercions or when we coerce to Boolean. And that happens to determine which values are truthy or falsy when we put them in a conditional or test expression like that if clause or the middle term of a for loop. We can also coerce to Boolean with the not operator or the double not operator as well. And then lastly, we just saw with the logical operators, the and or ors under the hood are going to evaluate the truthy and falsy truthiness of each of the terms as it goes through. Any questions on those? So there's one pitfall that always happens to beginners when we start to use these logical operators. And rather than see you go into the workshop and completely fuck it up over and over again, I just want to show one example. Basically, we want to know if a number is a vowel or not. And so I'm going to be really direct. I'm just going to hard code in if the thing is a vowel. So we want to say is vowel, and we want to know basically if Z is a vowel. Wow, I'm struggling with these two words. So most people, when they think of the OR operator, they want to use it how we use it in English. And so they're going to say if letter is equal to A, or E, or I, or O, or U. Does anybody know what this is going to be?
It's gonna be true and
Y. Oh,
Is it, they're all true, and then it's going to take the last term.
so what happens here is that this isn't how we say it in English. It's not actually doing if letter is equal to A or letter is equal to E. It's saying the thing is a vowel if the letter is equal to A or E is truthy or I is truthy or O is truthy or U is truthy. So in this case, Z is not equal to A, and we come to E, which is the first truthy value in this expression. And I don't have it in the test expression. So I literally get back that value, E, as the result of that line. So if I log that out, we see is vowel is E.
So it actually looks at the first term as just the letter A, just the string A.
I'm sorry?
So you're saying that like it looks at is vowel the letter A, and then it looks at everything else from the string state.
Yeah, so this OR operator is going to return the first truthy value. So if I plug A in over here, letter is loosely equal to A. And so that term here, this term here, evaluated to true. And so the OR stops. It doesn't even move on. It says I found the truthy value. That value is true. So that's what I'm assigning to is vowel. And when I switch it to a different letter, when we come over here, we say, hey, is E truthy? It is? Okay, just grab me this. So we have to think that these operators, they don't know what is on the other side of them. This letter equals doesn't get repeated over and over again. So in code, if we wanted to do it like this, we would have to come in and say, it's a vowel if the letter is equal to A or the letter is equal to E. And we have to repeat that all the way through. So it's not uncommon that this is the first way that people begin to write ORs, and then they have no clue why their function is returning true over and over and over again every damn time. Yes, I know her.
What about if you put 3 equal signs?
Yeah, so in this case, I mean Z, the string Z is still not equal to A. And so I was being really lazy here. I knew that I had a string, and I knew I'm comparing to a string, so I knew nothing wacky was going to happen. So I was really lazy, and I just put the 2 equal signs there, because I knew it's not actually going to coerce. They're both strings. However, as beginners, when we're still a little shaky on how this thing works, if we want to know if things are exactly the same, use the triple equals. Only use the double equals if you want the coercion to happen and you're aware of what's going to happen. But don't get lazy and type 2 equal signs just for the hell of it.
Okay, so if you type 3 equal signs there, will it come back for each vowel or string after the or symbols?
I'm sorry, so if I put letter triple equals A for all of these?
No, if you don't put it for all of them, but just for the if you took out the parentheses in the first string and had it just like took out parentheses there, and then would it then go through each one?
Okay, I'm not sure I understand, but here Z is not equal to A, so we don't have a truthy value yet, so we move on to explore
So what I'm
this.
asking you is the letter triple equal then going to apply to E?
It is not. So those parentheses were to visualize what is happening under the hood. But JavaScript sees each of these terms completely separately.
Okay.
It's never going to do what we do with English and we're able to repeat. We have to explicitly write out every instruction we want on each expression. These are all entirely own expressions.
Could you do it if you had it in the right?
Not sure what you mean. There are many ways that we could do it with the array. Yeah, we'll get to it. And so over here, so right now, if we would most likely use this in the if condition rather than save it as is vowel. So over here, it's saying, hey, is Z equal to A? Or is Z equal to E? And so the first term is going to evaluate to false. and the second term is going to evaluate to false. And so that whole OR takes the single value this resulted in, which was false. And it would coerce that, but false is already false. So this condition fails, and we go to the else. And I can change that here. And now we get it is a vowel. Any questions on anything from today's slides or anything at all?
I just kind of have, well, so these concepts, right? So like hearing you explain it or going through this whole, reading it in eloquent JavaScript or whatever, it's like kind of vaguely get the concept, but like how do we practice and actually use, like the logic or the thinking behind understanding this? You understand what I'm saying?
Yeah, so
Like,
the workshops are to actually practice, but it's kind of a lot at once. You have to solve this whole problem, and you might not be fully familiar with exactly what each line of code is doing. So the best thing I can say is to be intellectually curious, which means I hate the CodePen environment. It's really crowded. It's hard to tell your console logs. I recommend that you open up a REPL to start your function and then call your function at the end down here. So we say, hey, my test func like this. And now down here, I can control what it gets called with, rather than let the tests do all of the work. So that will take out some of the noise in the environment. But more importantly, in REPL, come in here, whatever thing you're trying to work on, do something like this. Play with it and log out the values. And then change it and do the opposite. And so really, you'll learn by trying to use these things and guess at what they're going to do, and then change data and see if it acts as you predicted.
See, I think so I do feel like I practice that, like I do those types of things, right? I feel like I do those types of things with kind of all the problems, but I don't really know enough yet to understand why things are happening or not happening, right? So like if I'm kind of looking at it like it works or it doesn't work, and I can kind of manipulate things a little until I get it to work. But I'm just asking, are there other tools that you would recommend to help us like gain that understanding?
Yeah, so there's nothing I can immediately tell you that will fill in the blanks. We have to learn by being curious and either testing code out or literally Google everything that you're unsure about. So we just type in JavaScript and whatever thing we're trying to learn about. And this blog, whatever's up here, might have a better English explanation of what's going on to help you form that mental map. And then to go play with the code and really solidify it. So really, when learning programming, it is what you make out of it. We can't settle for just letting the code work and feeling like we got lucky. We really have to make sure that we understand every expression in every line of code. And to do that, it's up to you whether you're going to play around and test it or Google around until you solidify that knowledge. But if you want to go down this path, you want to make that skill set as strong as possible. So never settle for not fully understanding what's going on. And lastly, reach out to Nick or me anytime you have a specific problem. Just message us on Slack and we can talk about it. And so while I say that, I'll just let you know, if there's anything wrong, like you can't access the workshop or you can't access the lecture video, don't just type it into the Slack channel because we don't get like instant notifications on that. Instead, don't hesitate to message Nick or myself directly because those direct messages will go right to our phone and we'll be able to answer you. But yeah, not exactly the best answer that you wanted. I don't have a shortcut or an easy way to get better.
I mean, you did actually answer my question, right? But I'm not necessarily looking for the shortcut, but just other tools or ways of approaching in which you actually.
Yeah, I'm not aware. I mean, there probably are some. If we Google around, there might be some like environments that will already have like test cases to visualize it. I'm sure they exist. I just don't know them off the top of my head. But MDN documentation, it might be a little in-depth, but if we read through it, I'm sure that we can find a few sentences that help explain it a little bit better. And down here are those 36 different rules for when comparing a Boolean with a string. And we see that under the hood, JavaScript is switching that Boolean to a number. I mean, it's switching operand A, which is a Boolean, to a number, and then it's switching the string to a number as well.
What website is this?
this is MDN. So most of the time we want to Google documentation about JavaScript, just type in MDN and then the concept. But usually JavaScript and whatever, the first link will be MDN. And the second one will usually be W3 schools, which isn't as great. So try to familiarize yourself with developer.mozilla.org. It's sort of the JavaScript Bible.
Say that one more time. That last
This subdomain up here, MDN, developer.mozilla.org. I'll link to this in Slack as well.
thing. Or if I could just type in MDN, it'll come up.
Yes, yes, definitely. Any other questions? All right, great. Let's take a 5-minute break. I'll open up the workshop, send out the pairs, and don't hesitate to use the help tickets for anything you're stuck on. We've got great fellows to help out as well today.